People don't care how much you know until they know how much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Malulenyo.
Magandang araw, Delphilorians!
Sa taong po ito, pag-iniwan natin ang isang radyo, mabuhay ang Pilipinas.
Kamusta? Ako si Teleo, ang batang teleradyo. Abangan niyo ako at ang aking mga kwento. La 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 la. Wow! Ang ganda naman ng gusali. Nagandaan ka rin ba? Iyan ang unang gusali ng Marcelo, na noon ay Bulacan High School. Binuksan ito ng mga Amerikano noong 1906 sa bakuran ng Kapitolyo. Nilarawan ito bilang the best and the most modern schoolhouse sa Pilipinas noong panahong iyon. Cool, di ba? Alam mo ba, ang unang gusali ng paaralan ay makikita sa logo ng Marcelo. Cool! Yan na muna for now. See you next time. Ako ulit si Teleo, ang batang teleradyo na nagsasabing, aming dakilang paaralan ay may dakilang nakaraan. Great school, great history. Bye-bye!
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo kahit magkalayo.
Good afternoon, Delpilarians. Welcome to the live coverage of Teleradyo Marcelo, ang telearalan ng bawat Malulenyo. Today is another episode of Exploring the Wonders of Science. I am Sir Arnold, and I will be your science teacher here at Teleradyo Marcelo. Just follow and like our Facebook page and subscribe to our YouTube channel. Do not forget to comment your name, grade, and section, for this will be your attendance in your science class. I am happy to share with you today things about the angle of release, height, and range of a projectile. The most essential learning competency is investigate the relationship between the angle of release and the height and range of a projectile. The learning competency code is S9FE-4A-35. Here are the objectives of today's lesson. At the end of the session, you should be able to, number 1, relate the angle of release to the height and range of a projectile. Number 2, describe the time of flight of a projectile when launched at different angles. Number 3, solve problems involving range, maximum height, and time of flight of a projectile. Let us recall first what we discussed last time about projectile motion. We are going to identify what is asked in each statement that I will be presenting. Let us start. Number 1. It is a body that is given an initial velocity and then moves in a parabolic path determined by the effects of the force of gravity. Comment your answers now. Very good. The answer is projectile. Number 2. It is the time taken by the projectile to move from the maximum height to the lowest level of trajectory. Send your answers now. You're right. The answer is the time of descent. Number 3. It is the time from when the object is projected to the time it reaches the surface. What is the answer? Very good. The answer is time of flight. Number 4. It refers to the point reached by the projectile wherein the piece of y is equal to 0. Comment your answers now. You're right. The answer is highest point. Number 5. It is the horizontal displacement of the projectile. Very good. It is referred to as the range. To recall, a projectile is a body that is given an initial velocity and then moves in a parabolic path determined by the effects of the force of gravity. The effects of air resistance are negligible or non-existent. A projectile may be launched at different angles. This launch angle theta pertains to the angle in which the projectile is released. This is usually measured above the horizontal axis. A projectile launched at angle theta pertains to a non-horizontally launched projectile. What do you think are the three quantities related to projectile motion that are affected or determined by the launch angle? Comment your answers now. Very good. These are the time of flight, the range, and the maximum height reached by the projectile. The maximum height reached, or the highest point the projectile will rise, is determined by the launch angle. the range or the horizontal displacement traveled by the projectile is also affected by the launch angle. The time of flight or the time the projectile is in the air is also determined by the launch angle. Let us have this activity to compare the horizontal distance traveled, the maximum height reached, and the time of flight of projectile launch at different angles above the horizontal axis. I will be giving a situation. After that, I will be presenting statements and you are going to fill in the blanks with the correct answers based on the situation given. Here is the situation. A ball is kicked at 5 different angles by the player in a field where there is no significant amount of air resistance. The angles are measured above the horizontal axis. These angles are 15 degrees, 30 degrees, 45 degrees, 60 degrees, and 75 degrees. Take note that the initial velocity of the ball is the same. Let us start. Number 1. The ball kicked at 5 different angles follows a blank path. What is the answer? You're right. It is parabolic. Number 2. The ball kicked at the angle of blank travels the farthest horizontal distance. Send your answers now. Very good. The answer is 45 degrees. Number 3. The ball kicked at the angle of blank has the highest point reached before falling to the ground. What do you think is the answer? That is correct. It is 75 degrees. Number 4. The ball kicked at the angle of blank reaches the ground first. What is the answer? Very good. The answer is 15 degrees. Number 5. The ball, when kicked at angles of blank and blank, travels the same horizontal distance or range. We have 2 sets of answers for this statement. You are right. The answers are 15 degrees and 75 degrees. The other answers are 30 degrees and 60 degrees. What do you think are the reasons for the answers that we have in the activity? Let us consider first the components of the initial velocity of the projectile. These are v sub ox, the horizontal component of initial velocity, and v sub oy, the vertical component of initial velocity. These 2 components will be used in explaining the answers that we have in the activity. When the launch angle is changed, the components of initial velocity, which are v sub ox and v sub oy, also change. Let us compare the v sub ox and v sub oy of the initial velocity at 3 different angles, which are 30 degrees, 45 degrees, and 60 degrees. Take note that the initial velocity v sub o is the same. The initial velocity v sub o measured 60 degrees from the positive x-axis has the greatest v sub oy, while the initial velocity v sub o measured 30 degrees from the positive x-axis has the greatest v sub ox. The highest point reached by a projectile is determined by the value of the vertical component of initial velocity V sub OY. The greater the value of V sub OY, the higher the projectile will rise. Since steeper launch angles have a larger vertical velocity component, increasing the launch angle increases the maximum height. Among the angles given in the activity, the 75-degree angle gives the initial velocity the greatest value of the vertical component V sub OY. That is why the ball kick at 75-degree angle has the highest point reached before falling to the ground. The ball kick at 15 degrees has the lowest point reached because the value of the vertical component of initial velocity V sub OY is the smallest among the angles given. The maximum height h reached by the projectile is calculated by using the equation h equals v sub o squared sine squared theta sub o divided by 2g, where h is the maximum height reached in meters, v sub o is the initial velocity in meters per second, theta sub o is the initial launch angle in degrees, g is the acceleration due to gravity, which is equal to 9.8 meters per second squared. Take note that sine squared theta sub o is equal to sine theta sub o quantity squared. The time of flight t of the projectile is also determined by the value of the vertical component of initial velocity v sub oy. The smaller the value of v sub oy, the smaller the time of flight. Since steeper launch angles have a larger vertical velocity component, increasing the launch angle increases the time of the projectile in air. The ball kick at an angle of 15 degrees has the shortest time of flight, so it is the one that reaches the ground first. The ball kick at an angle of 75 degrees has the longest time of flight since the value of the vertical component of its initial velocity is the largest. The time of flight of the projectile is calculated by using the equation E equals 2b sub o sine theta sub o divided by g, where t is the time of flight in seconds, v sub o is the initial velocity in meters per second, theta sub o is the initial launch angle in degrees, g is the acceleration due to gravity, which is equal to 9.8 meters per second squared. The range of the projectile is determined by the value of the horizontal component of the initial velocity v sub ox and the time of flight t. The ball kick at an angle of 15 degrees has the greatest value of the horizontal component of initial velocity, but it cannot travel a long range since its time of flight is so short. The ball kick at an angle of 75 degrees has the longest time of flight, but its range is limited by the smallest value of horizontal component of initial velocity. Why does a projectile launch at an angle of 45 degrees produce the maximum range? It can be best explained by looking at the formula and getting the range of a projectile. The range of the projectile is calculated using the equation r is equal to v sub o squared sine 2 theta sub o divided by g, where r is the range of the projectile in meters, v sub o is the initial velocity in meters per second, theta sub o is the initial launch angle in degrees, G is the acceleration due to gravity, which is equal to 9.8 meters per second squared. So, why does a 45-degree angle give the maximum range? The value of sine function is highest, which is 1 when the angle is 90 degrees. Based on the formula, in calculating the range R of the projectile, sine 2 theta sub O is equal to 1 when theta sub O is 45 degrees, since 2 times 45 degrees is equal to 90 degrees. Let us go back to the answers to this statement that I have given earlier. The ball, when kicked at angles of blank and blank, travels the same horizontal distance or range. The answers are 15 degrees and 75 degrees, and 30 degrees and 60 degrees. What do you call these angles? Comment your answers now. Very good. These angles are called complementary angles. A projectile launched at 30-degree angle will achieve the same range as a projectile launched at 60-degree angle, provided that the initial velocity is the same. Since these two angles are complementary, projectiles launched at these angles will strike the ground in the same position and travel the same horizontal distance or range. They will just differ in the time of flight and in the maximum height reached. Let us now solve a problem. A football is kicked at an angle of 20 degrees from the positive x-axis with an initial velocity of 22 meters per second. Neglecting air resistance. A. How high does the ball rise? B. How far horizontally does the ball travel? C. What is its time of flight? The given quantities are theta sub O equals 20 degrees, P sub O equals 22 meters per second, G equals 9.8 meters per second squared, and we are going to look for A, maximum height reach or H, B, range or R, and C, time of flight or T. For letter A, the formula or the equation to be used in getting the height of the projectile is H equals B sub O squared sine squared theta sub O divided by 2G. Substituting the values, we have H equals 22 meters per second quantity squared times sine squared 20 degrees divided by 2 times 9.8 meters per second squared. H equals 2.9 meters. This tells us that the football rises to a height of 2.9 meters. For letter B, to get R, we are going to use R equals B sub O squared sine 2 theta sub O divided by G. Substituting the values, we have R equals 22 meters per second squared times sine 2 times 20 degrees divided by 9.8 meters per second squared. R equals 484 meters squared per second squared times sine 40 degrees divided by 9.8 meters per second squared. R equals 32 meters. The football has a range of 32 meters. For letter C, to get the time of flight, we are going to use T equals 2B sub O sine theta sub O divided by G. Substituting the values, we have T equals 2 times 22 meters per second times sine 20 degrees divided by 9.8 meters per second squared. The time of flight T is 1.5 seconds. The time consumed by the ball to move from starting point to the point where it lands is 1.5 seconds. Now, let us have this assessment to measure how much you have learned from the discussion that we had today. I will present each question and the choices. Choose the letter of the correct answer. Let us begin. Number 1. You throw a ball with the same initial velocity at different angles. 10 degrees, 20 degrees, 40 degrees, and 50 degrees. Which two throws cause the ball to land the same distance away? Is it A, 10 degrees and 20 degrees, B, 10 degrees and 40 degrees, C, 40 degrees and 50 degrees, or D, 20 degrees and 50 degrees? What is the answer? Very good. The answer is C. Number 2. Which of the following launch angles will cause the object to have the shortest time of flight if the initial velocity of the object is the same? A, 15 degrees, B, 45 degrees, C, 60 degrees, D, 75 degrees. Comment your answers now. That's right. The answer is A. For numbers 3 to 5, refer to the situation given here. A ball is thrown at a launch angle of 15 degrees with an initial velocity of 5 meters per second. Another ball is thrown at a launch angle of 75 degrees with the same initial velocity. Number 3, how will you compare the horizontal distance traveled by the two balls? A, the ball launched at 15 degrees travels the longer horizontal distance than the ball launched at 75-degree angle. B, the ball launched at 15 degrees travels the shorter horizontal distance than the ball launched at 75-degree angle. C, the ball launched at 15 degrees travels the same horizontal distance as the ball launched at 75-degree angle. D, it cannot be determined. What is the answer? Very good. The answer is C. Number 4, how will you compare the maximum height reached by the two balls? A, the ball launched at 15 degrees has the higher maximum height reached than the ball launched at 75-degree angle. B, the ball launched at 15 degrees has the lower maximum height reached than the ball launched at 75-degree angle. C, the ball launched at 15 degrees has the same maximum height reached as the ball launched at 75-degree angle. D, it cannot be determined. Send your answers now. That is correct. The answer is D. 5. How will you compare the time of flight of the two balls? A, the ball launched at 15 degrees has the longer time of flight than the ball launched at 75-degree angle. B, the ball launched at 15 degrees has a shorter time of flight than the ball launched at 75-degree angle. C, the ball launched at 15 degrees has the same time of flight as the ball launched at 75-degree angle. D, it cannot be determined. What is the answer? Good job. The answer is D. Do you have any questions? If none, thank you, grade 9 learners, for actively participating in our discussion. Thank you to my dear science family, to my master teacher, Ma'am Rodeline M. Kaluwag, to our officer in charge, Ma'am Mirna L. de la Cruz, to our beloved principal, Dr. Maria Victoria Sibuibo, and to the staff of Teleradio Marcelo, and to our Almighty God. Let me end this session with this quotation. Life is like riding a bicycle. To keep your balance, you must keep moving. From Albert Einstein. Again, this is Sir Arnold. I hope you will have a wonderful afternoon. Thank you, stay safe, and God bless.
Teleradio is always at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa Teleradio. Please take time to send your feedbacks via Teleradio Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow. bit.ly/3ORVAY9. Kaya send your hashtag PBH o hashtag RT dito sa Teleradio Mu kung saan ang feedback mo, suggestions nyo ay mahalaga sa Teleradio.
Makinig, manood, nasa Teleradyo. Makinig, manood, nasa Teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo.